Good evening, everyone. Today, we welcome you to the 21st Computer Engineering Seminar about the Radarbase, which is a platform for remote patient monitoring. Today's session will comprise an introduction to the Radarbase, and we will explore some of the key challenges that needed to be addressed to build a platform like Radarbase and some of the case studies where it can be used. Let me introduce our resource person for today's session, Ms. Nivethika Mahasivam, the product manager of the Radarbase platform at the Hyve. She is responsible for leading the product development team of Radarbase. She has been working on Radarbase and remote monitoring technologies, connected health for the last 6.5 years and helped researchers and representatives from organizations who would like to run remote patient monitoring trials. Ms. Nivethika has completed an international master in service engineering, and she is also an alumnus of the Department of Computer Engineering, Faculty of Engineering, University of Peradeniya. If you do have questions for our speaker, you may raise them at the Q&A session at the end. You can use the chat section in Zoom as well. Without much ado, let us begin today's talk. I now hand the session over to Ms. Nivethika.
Thank you. All right, so you can already see my screen, so let's get that started. So first of all, thank you very much for this opportunity to be able to share what we have been working on for the last 6.5 years.
Ms. Nivethika, you're muted. Excuse me.
Right, okay, sorry. Okay, so, thank you very much. First of all, thank you very much for giving me this opportunity to share what we have been working on for the last 6.5 years. And okay, so for today, I will start with a short introduction of myself and where I work. And then I will be sharing some insights of the Radarbase platform, which is the main topic of discussion today. And I will go into some of the background, what motivated us to build this platform, some of the key features, and some high-level architecture concepts to give you some insights on what kind of technologies are used to build the platform. And then I will go through a few of the use cases where the platform has been used.
Nivethika, you're muted again.
All right, I think it's my mouse playing up. Okay, so I hope now you can hear me. Okay, so my name is Nivethika Mahasivam. I, just like most of you, I started at the University of Peradeniya. I graduated from computer engineering department, and then I worked as a software engineer in Sri Lanka for a couple of years. And then I came to Europe to do my high studies. So I did an international master's in service engineering, which is sort of a multidisciplinary master's, combined information management and business processes. And afterwards, I did my master thesis / internship at Sintef, which is an independent research organization in Norway. And then I joined the Hyve as a software engineer. Well, that's interesting. It doesn't say the Hyve, but I joined the Hyve as a software engineer in 2016, where I joined the team to build the Radarbase platform, which we're going to be talking about. And later I moved more into product development, and right now I'm the product manager of Radarbase at the Hyve. And all right, so just a few words about the Hyve. The Hyve is a company all with IT and data experts who work mainly in life science domain. So what we do is we specifically work in open science and open source softwares in the domain of life science research. And we also help organizations to make data more fair in the life science domain. And yeah, just a bit of numbers. We are active for the last 10 years, and mostly we work with most of the top farmers in the world, and also a lot of public universities, research centers, medical universities, etc. And next to that, we also work in a lot of pre-competitive initiative, or what you call like large grant projects. And that is where we work in a pre-competitive stage, looking into some research and innovation. And these are some of the products that we work in. And I will be talking about database, which is where I work in. Okay, so I want to start with the motivation behind this research, the initial research study that started the database platform. So ideally, in a normal setting, how you measure and assess a disease is, it used to be when patients started having adverse complaints, and then they go to the doctor or to the GP, and then they run some tests, and then they figure out, okay, this is what's going on, and then you are officially diagnosed with a particular disease. And then afterwards, you have some follow-ups to check the disease progression, and then you take measures to manage the disease. And from there, we move to a stage where, people are more aware, more careful about some of the conditions they could have. So, people with the risk category, but also the healthy people also sometimes go and measure. So we do have more insights on the prodrome stage. So that is when you start to have some symptoms, but you're not clinically diagnosed with the particular disease. And then also the people who are particularly diagnosed, and then at that stage you take maybe a bit more measurements to see what's going on, and then it goes on. But still, these measurements are quite intermittent, and you just get routine measurements, but it's not continuous. So with this way, you don't really have a lot of insights on what exactly is causing a disease, and what is the best way you can manage a particular disease. And until now, these disease measurements and assessments are done based on some validated clinical measures and biomarkers that are already out there. So, and another motivation for this project is to also look into when you have chronic diseases, or in certain diseases you can have relapses. You may think that your disease is controlled, but then after some time you can relapse, and then you can have more severe complaints. So usually, the relapse happen when the severity of the symptoms, they kind of increase. And then when you have higher symptoms, you go to a doctor, and then you find that, okay, you are in the relapse. So when you find out that you are actually relapsing, then it's a little bit late to actually intervene or take an action. And another question is, there is the relapse prodrome stage, where you actually will start to see some symptoms. And if you have a continuous measurement, can you actually infer a relapse that's going to happen? And by inferring, can you do something to prevent this relapse from happening? So these are the motivations for such programs to measure more continuous and pervasive passive data collection. So that means that you have a complete, continuous insights on patients' lives and their health measurements, pre to post-disease stages. And with that, you can assess a disease based on validated digital measurements and digital biomarkers. So on the other hand, as you all know, the technology right now, it has gone far, and a lot of people are already using wearable devices, activity trackers, mobile phones and apps to manage and self-manage their health. And also if there are people with a particular disease, they're also more motivated to use these technologies to manage their disease. So the idea is that you can actually have a lot of digital measurements around a particular participant using these, monolithic devices that you use in your day-to-day life. And the main motivation for you doing this continuous measurement is to also study a participant in their normal day-to-day activities when they are at home doing certain things, because these are the events that lead to a relapse or lead to a disease. And studying those instances is also quite important to get a full picture of what's happening in a particular disease area. So how do you go from these kind of digital measures to something more concrete in a particular disease? So you would first just gather this kind of various vital signals or raw data from sensors and mobile applications. And then you have studies and data collections done. And in that, you have sort of a low-level data capture and management. So that's when you will know, okay, this is actigraphy and some speech features and heart rates and heart rate variability, etc., etc. And then by collecting and analyzing, you can build algorithms, and these algorithms will give you high-level markers. And if you do this in a continuous studies, and then if you find out, you can actually map these high-level markers or combination of high-level markers to a particular disease area or a particular stage of a disease area, then this can be further taken into kind of a validated and more qualified digital biomarkers. And when the digital biomarkers are properly validated, and then you can also use it in clinical trials to do drug development. So this is the motivation for doing such research. And what we're going to be talking is about the technology platform that allows you to get this data from various devices and applications to a place where you can go and build your own algorithms. So how the Redder-based platform come into play. So the Redder-based platform started with the initial research study, which is called Redder CNS. Redder, as it stands for Remote Assessment of Diseases and Relapses, and CNS stands for Central Nervous System. So the Redder CNS project, it aimed to look into 3 different disease areas in the central nervous system. One is major depressive disorder. The second one is epilepsy. The third one is multiple sclerosis. And the goal of the research study is, as I explained, like, can you actually use wearable devices and applications to measure this kind of the targeted disease areas, and can you actually predict these relapses? So can you detect these relapses, and from there can you go further into predicting and preventing this from happening? So within Redder CNS, we had 3 different disease areas, and these 3 disease areas, they have really different nature of relapses, and what causes them are also different. So you need to look into different type of data modalities and functional domains to understand this particular disease. So for this project, we needed a platform that can, get data from different wearable devices and applications, and get all of this data into one place in a way that you can easily adapt or extend to additional devices if needed. So the platform started in this project. So that is when we started doing the early stage design. And of course, the first study which uses the platform was one of the CNS studies. But during this stage, we figured, okay, this is something that can be used outside this project, because there was already a lot of interest in such applications and doing more research in this domain. So we made this platform an open source platform, and we launched it as the Ready-based platform in 2018. And since then, we have been we have been working a lot into improving the maturity of the platform, making it more scalable, building in new integrations and features, etc. So since 2017 onwards, the platform also has been used widely outside the Reda CNS project. So Ready-based, it's a platform for remote assessment of disease system relapses. And it does both passive and active monitoring. And I'll go a little bit deeper into what kind of data collection or ingestion is possible. So the passive data monitoring is when you monitor a particular participant passively, which means the participant is not intervened, and they're just, in their ideal day-to-day living setting, they don't have a lot of, they don't have to do a lot of things actively to contribute to the study. So you would be collecting data from wearable devices, fitness trackers, or just data from your applications. So as part of the project, we also built two mobile applications. One would be collecting sensor data from your phone itself, or it will use the native sensors in the phone, and it will give you some insights. And then in addition to that, if you compare some medical graded devices, they would share the raw data, but then you need to get this raw data using Bluetooth extension. So this passive RMT app would also pair with these devices and then stream these data in real time. And on the other hand, if you consider consumer-based devices like Fitbit or Garmin, they first send the raw data to their cloud platform, and then they give you APIs to download this data. So this is sort of a cloud to cloud or cloud to your own premises data download method. And then in some cases, there are some wearable devices where they don't have any of these methods, no SDK or no cloud access or any other access. What you get is just the raw data or process data. And in that case, what we have is you can upload this data into a web portal, and then it is processed with all the other data that we have. So you have all of the data that you collect from participants aligned together. And next to that, we can also do active remote monitoring. So active remote monitoring is when you want to have periodic data collection from the participants. So this would include like surveys, questionnaires, and electronic patient-reported outcomes. So electronic patient-reported outcomes are validated clinical outcomes assessment tools, so which have like a really validated questionnaires and scores underneath. So based on the answer they provide to the questionnaires, you can calculate the score, and then that score would tell you where exactly you are in a particular disease. So often the combination of active and passive remote monitoring can be really interesting. to get a good level of understanding of how a particular participant is doing, because the active remote monitoring would actually give you more immediate insights on how a particular participant is doing, because the participant can reflect immediately on how things are going, whereas there will also be the passive data which will complement the outcomes that's reported by the participants. So the core concepts or the requirements of such platforms is that it has to be modular and extendable. Because for different diseases, you would look into different domains, which means you need to work with different types of wearables or devices or apps where it's applicable. So, and also this wearable market is also quite agile. So there are like lots of new devices coming, lots of devices that are already in the market. They're out of the market. So you need a platform that can work with all of this. That's flexible enough. You can add new modules easily, and it captures data in real time. And at the end, everything what you see in the blue box is also quite streamlined, because we want to put as less work as possible when it comes to supporting a new device. So we have an architecture and a pipeline that's implemented so that everything that's coming into the platform and how it's processed, etc., is quite streamlined across different data ingestions or wearable devices. And last but not least, the platform is open source, and we also try to use open source technologies to build the platform itself, so it can be sustained as an open source platform. Here you can see some of the devices and apps that are supported. The radar-based passive RMT and active RMT are the apps that we have built as part of the platform. So as I said, that the passive RMT, it can get data from the native sensors, or it can pair with additional devices. And the active RMT gathers questionnaire data. And next to that, you have Nivethika and Bitchin. These are more of medical graded devices. It gives you raw data into some body signals. And then these are more of a consumer-based devices, which give you aggregated data into your activity, and DREAM is particularly used to give how do I say it, like to monitor your sleep and in which particular stage you are in your sleep. And in addition to that, you can also get EEG data from DREAM. And at the bottom, these are devices that we have integrated for a study for Alzheimer's disease, or these you would use to measure cognitive function. For example, the banking app, based on you will receive some transactional task or like a banking task, and based on that they would be able to decide how well your cognitive function is. All right. So another thing that we had to keep in mind is when it comes to real world data, there's also challenges in getting this data. Obviously, the data is heterogeneous, different devices provide data differently from each other, and the data can be quite unstructured. So which is why we had to build a platform that can automate as many things as possible and get the data in a structured way. There can be missing data, so you need to have methods to identify if there is missing data and then make an action to prevent it or reduce the detect that the compliance is going low. And most importantly, privacy and security concerns, because we are dealing with health data. It's a really sensitive data. and the privacy of the participants and the security of the data that's being transferred and stored is really important when it comes to such platforms. So these are the key aspects of the platform. So the first is the flexibility and scalability. So we use a scalable solution. Most of them can be distributed. So you can use this platform for a study with 10 to 20 participants or thousands of participants, and you can use a bigger compute if you want to scale up to a bigger trial. And we also use OAuth2 and standard APIs to do the integration, because one important aspect of this platform is that we should be able to work with different devices, different platforms that are out there. And OAuth2 is one of the common standard to do integrations and authentications. And the platform is fully containerized, so we use Docker to Dockerize the platform, and we also have a configurable stack to deploy it, so that you can actually deploy this platform in any infrastructure that you have. So it can be deployed in a private infrastructure or in a public cloud, wherever you like. So because in such cases, the ownership of the data is also really important, because different sites, they want to be the owners, and it's also important that a particular data, it doesn't transfer from one country to the other. And most of the researchers or study coordinators, they like to have this data located in their own premises or in an infrastructure where they have control of. And the second one is data compliance. There are a lot of methods implemented to avoid data in conformance. So as the data come in, we have methods to check if a particular data is compliant to the data schema. And there are also real-time analytics capabilities to detect anomalies. So these can be, for example, we can detect if the battery of an Nivethika device is too low, then the device would stop sending data, so you can send a reminder, for example. Or if you detect a particular device is disconnected, or that we are not receiving data from that participant anymore, then you can make a call or make an intervention to see what's going on. And there's also a data compliance dashboard, which gives like an overall high-level idea on how the study is progressing, how continuous the data is, so that you can also find out if a participant is compliant and if you're receiving the data that you're expecting. And at last, the data repository, because at the end, this is what you get from the platform, the data that you collect, so that you can run you can build your algorithms and analytics to figure out what's next. So we use standard S3 API, so it's compatible with all of the most of the standard object storage that are available, and we use Minio to host database as a standalone service. So it also includes a Minio instance where we will be storing the final results or the data that's collected. And we use open formats and open schemas in the platform, so that when you get the data at the end, a researcher or a data analyst can look into the data schemas, and the schema is in a human readable and documented form, so you can understand actually what type of data is collected and how it's collected, for example. And also, most importantly, the data is structured and it's time-stamped. So now I will dive a little bit into the architecture concepts. I won't go into too detailed. So the main concepts that we have in the platform is that it's real time, so it's event based. The platform is based on Apache Kafka, so it's a event processing. It's a distributed event processing system, and in Kafka you have topics which can handle different data streams. So for example, we have one topic for accelerometer and another topic for gyroscope, etc., etc., another one for heart rate, another one for sweat conduction, etc. And then second one is it's modular and pluggable, and we also use microservices to address if there should be a new feature. So for example, there are different levels of data ingestions, as I explained. So the platform is built in a way that if you have to add support to a new device, then you have to either add a new module or you have to extend a plugin in a particular module. And platform is distributed and scalable, as I said. And another important factor is that the identifiers, we use pseudonymized identifiers, so the data that we collect is also not particularly personally identifiable information. And in this case, these data are stored separately. And the patient-generated data, which is the data that you collect from the data sources, from the wearables and apps, is stored separately in the data repository and from the metadata that you collect. So there's also metadata about which participant is in which study, what kind of data sources are they using, and sometimes it also includes demographics, and these are stored separately. And the data is transferred and stored securely. The data is transferred using encrypted protocols. We mostly use just HTTPS. And the data, at the end, you can install this platform on an encrypted storage so that the data is also quite safe at the end of the day. And so one important and unique perspective of Redis is the way we build Redis schema. So the first thing we do when a particular device or an app need to be integrated, we investigate what kind of data we need to collect from this device, and then we create data schemas. We use Apache Avro to create these schemas. Apache Avro is a data format, and it's used other technology. I'm not particularly sure, but it's used a lot in Apache Kafka, and it's a compact way of transmitting data. So as I said, then we have from a particular wearable or a device, you check what kind of data you want to collect. There's often more than one data modalities you want to collect from a particular device, like, you have accelerometer, magnetometer, gyroscope, etc. And then you check what kind of data you need. And each of this data stream is sent to a separate topic. And each topic is mapped to a particular schema that we create. And at the end of the day, there's a specification or a catalog. So per device or per data source, we have a schema specification that would map, okay, this is the data stream. For this data stream, we will be using this data topic, and this is the data schema of that data point. And there are also a lot of utility tools built around it so that, this can be streamlined down the line where it's used. You can actually check these schemas in the repository, and these schemas are also packed with the data that's provided to the researchers at the end. So one thing we do when we do the integration is the data harmonization, or the schema harmonization more specifically. So for example, we also analyze this data quite well to find how well this can be harmonized across devices, because you would get accelerometer from multiple devices, but the accelerometer data is the same. So if you have an algorithm that would work with accelerometer, then you should be able to run that algorithm in data that's collected from any device that can give accelerometers. That's the whole of this kind of, that's the aim of this kind of harmonization. So for example, if you see the schema of the phone accelerometer looks almost the same as the Empatica for accelerometer. And so at last, this is the high-level data flow and of the database. So the data sources would be sending data to the platform using REST API or using connectors. So another good thing to know is that our architecture is mostly based on Confluent ecosystem. So there's also the concept of source connectors and sync connectors. So you have source connectors, which will be data producers who will be sending data to Apache Kafka cluster. And these source connectors also have particular converters that we have built so that it would be able to understand data from these data sources and convert that into a Kafka message. And it will attach the Avro schema that we have created for that particular Kafka message that it creates and send to the Kafka cluster. Then the Kafka cluster will process it and put it on the right topic extra. And we also use REST API to capture data, but the REST API will also do the same. It will either transfer that data back into a source connector, or the REST API would send it to the Kafka cluster itself has a REST proxy, which will be able to do the same thing as source connectors. And these source connectors, they also check with the schema registry to get the right schema that's registered for that particular data stream or the topic. And on the other hand, when it comes to data extractions, you have sync connectors. And the sync connectors will work with the schema registry to read the data and then deserialize the data that it has read from the Kafka brokers. So why this is important is you have multiple data sources streaming into the platform, and you want to have this kind of architecture so that these multiple source connectors are actually multiple data producers, so they can send data into the Kafka cluster in parallel. They wouldn't depend on each other. The same goes to sync connectors. They will be having multiple consumers, and these consumers can actually consume data from a single topic at the same time. And another reason why this is important is the way that the modularity of the platform. So for example, we have a particular source connector to process data from cloud to, like, to receive data from REST API, and another connector to receive data from sources, data that are uploaded manually, and another connector to just receive data from REST API or from the passive app. And the same goes to sync connectors. The sync connectors can, download the data and write it to local file system or write it to the object storage. So we used to have one sync connector earlier, which was writing into a Hadoop file system. And then from Hadoop file system, now we have moved into object storage. Then the only thing that we had to change was this sync connector from HDFS sync connector to S3 sync connector. So this kind of feature, and the modularity and extendability is really crucial for this platform, so that you can kind of adapt as you go when new needs and requirements come. And another thing in the platform is that we also have our own study management portal, which you would use to manage users' studies and study participants and the data sources that they have, etc. So this will be the main system the researcher or the site coordinator would interact with, and they would use this system to onboard participant, fill in the information, and pair one participant to the app, so that the system knows this participant is actually using this app, and this app is a validated secure data source, and we can receive data from this data source. The same goes to all data sources. There should be some sort of authentication and validation that needs to happen. So for if it's a Fitbit, then we also need to connect a Fitbit account to a participant record that we have in the system. And this thing also needs to be automated. And this management portal also behaves as the identity provider in the whole database ecosystem. So it does it controls the user identity, and it also provides user roles based on role-based access control. So, like for example, there can be users with multiple roles, and there are project-based roles. So one particular who have access to one project can only access resources in that project and data, for example. This is a high-level architecture of the platform. So as you can see, all of the data, there are multiple middlewares and connectors that we have. So these are the client-facing applications that we have. And these applications would capture the data and send it to the platform. There's a database gateway, which will receive the data first, and then it will check if the data is coming from an authenticated user. And it will also check if the data is conforming to the schema that is expected, and then it will transfer it further down the line in the pipeline. And the management portal is all of the data that comes in is also checked with the management portal to make sure that it's authenticated and authorized to do certain actions that it's meant to do. And then, as I said, it's also possible to do real-time analytics. There are different use cases to do real-time analytics. We don't do that always. And we have two sync connectors, ideally, in most of the settings. One, it will continuously download the data and put it in an object storage, which we consider as a cold storage. So then you take this data at the end of the study or after one significant stage of the trial and then analyze it. Then we have another sync connector, which downloads the data in real time and store it in timescale DB. So timescale DB is particularly built to handle time series data in progress, Postgres. And on top of that, we have a Grafana-based dashboard. So this is sort of a easy and scalable solution that we came up with to build the data compliance dashboard, so that you will be able to see how many data points we have received in near real time. Okay, so next I will be going into some of the use cases that we have done or where the platform has been used. One is for the trial at home service for Center of Human Drug Research in the Netherlands. So they work with pharma companies or hospitals to do clinical trials that are used in further used in drug development. And their aim is also to figure out if you can actually do, early stage clinical drug development trials using validated remote monitoring methods. So for this, what we have done is to kind of adapt the platform with additional capabilities. So we have integrated with things device ecosystem, and also customized the application, the PRMT application we have. So they use this platform into pediatric and respiratory areas. So we integrated with Nuo Air, so it's a spirometer, and based on the spirometer, you can also see how well your lung is performing, which is more important if you want to look into asthma and respiratory conditions. I think one important thing to know is that this is also one area where the platform is further validated and it meets the 21 CFR Part 11 and other compliance guidelines. So these are crucial if you want to use this kind of methods in drug development trials. And the second case study is from Reda CNS, the initial study where the platform started. One of the disease area was epilepsy. So the objective of this study is an observational study. So observational study is that, you come into a particular clinical setting and you're observed and see how you're functioning. So ideally, when you have epilepsy, how you are monitored is using EEG, because when you have epilepsy, you have seizures, and the way to measure seizures is to using EEG. So these participants, they were in a hospital, and they were having the EEG, and they were also recorded using a video, and they were wearing the wearable devices that were integrated with the platform. So the goal of this study is to figure out if you can actually record seizures using wearable devices. So for this particular study, they used Nivethika Mahasivam, which is a medical grade device, which also gives raw data and in a high resolution. So for example, this is a comparison between when the video and EEG recorded when an like a seizure has started and ended, compared to the data that you collected from Nivethika Mahasivam sensor. So what you see is this is the accelerometer and this is blood volume pulse. So when the seizure is happening, you can clearly see that they have the tremors and the people are moving or shaking. And at the end of the seizure, you would also often sweat. So there's also an increase in the electrodermal activity, which indicates that someone is sweating. So the main conclusion is that at least using these remote monitoring technologies, we are able to record seizures. I don't know, I think I should have the numbers in the slides before. So this is the next use case where it was from the same project but focused on multiple depressive disorder. So when in the depressive disorder, they were interested in studying how, for example, particular participant's mood is behaving and how their activity is comparing to their mood behavior. So PHQ and RSES are some validated tools, questionnaires that measures people's mood and how happy they are. So that can give a clear indication of if a particular participant is depressed or not. So these are data that we collected from a particular participant on per day. And this activity is, this participant is relatively active. As you can see, except the time that person is sleeping, this person is moving well, except these 2 days where we don't have data. But other than that, relatively speaking, this participant is active. And if you compare that data with the PHQ and RCS scores, which are quite high, which indicates that this participant is not depressed. So, which means there are ways that you can actually use this kind of digital measures and find out if a particular stage in the disease or a particular participant is depressed or not in this specific case. Yeah, so this is the protocol of the study. So they were interested in understanding the sleep patterns and social isolation, and how if there's a connection between social isolation and sleep patterns in when a particular participant is depressed. Yeah, so these are also some screenshots from the active RMT app, which collects the patient-reported outcomes. And next to that, they were using Fitbits and the passive RMT app, which got some passive data. This is another use case, which is slightly different from the other use case. So in this study, the objective was to reduce the gap in the knowledge of people's health and well-being of the people who migrate to UK. So, this particular subset of the population and how good they are doing, how easy it has been for them to integrate into the country, get used to the national healthcare system. This part of the knowledge has been missing. The goal of the study was to reduce that gap. And eventually, if they find out where there are challenges, then they can talk with the policymakers and advise them to make suitable changes. So what was different in this study was that they wanted to do just public campaigns, and the patients would voluntarily opt in to take part in the study. In the other studies, these participant recruitments are done on site. So you would really talk to a researcher, and this researcher would explain what the study clinical trial is, what kind of data is going to be collected. They will explain you, this is how you have to use the app, this is how you have to use the device, etc., etc. And the consent of the study is also done outside the platform. Whereas in this case, the participant should get all of the information about the study and provide consent on the app. So for this study, we modified the open source app into a different app. So we added some custom features so that it can be used for this purpose. So we modified, we also had to change the architecture a little bit. Thanks to the way the platform is built, you can actually, add or remove some part of the components of the platform. And then we built in self-registration and e-consent in the app so that this can be used publicly and people can opt in. And, such technologies can still be used ethically in practice. So there are some. So this is how the app looks. So I don't know if you remember the screenshots from earlier. This looks quite similar, just with a different theme, and it has some additional screens or workflows to do self-registration and consent management. And the outcomes of the studies are like it was well received. About 650 participants volunteered to join the study, and they stayed in the study from 67 countries, which means all of the participants were in UK, but they are migrants from 67 different countries. And another goal of the studies is to also do micro-randomized trials to find out what kind of surveys or protocols would result in higher compliance. So they also did like a micro randomized trials, if you will, so that like one group would get one protocol, and there would be some slight adjustment to the next round. Likewise, they studied which particular subgroup has higher compliance. So this data shows what results in higher compliance. For example, twice a week questionnaires are more appreciated than once a week. Then people tend to get they forget about the study. And we also send notifications and reminders, and they do appreciate it if the notifications are sent at 9 p.m. instead of during daytime, because they are often busy, they are at work or doing something else, and after 9 they can actually get on and participate in the study. Yeah, and also, like, for example, the short text notification and reminders were better appreciated than the reminders and notifications with longer text. So the last use case I have is called Reda AD. So this is similar to Reda CNS, but this was applied for Alzheimer's disease. So the goal of the study is to also figure out if you can actually use mobile and digital technologies to improve the assessment of Alzheimer's disease, or in general, functional and cognitive decline. This study is 3-tier studies. So how the study is designed is that there will be the first tier, and the participants will be wearing 2 activity trackers, the passive RMT app from, they will have the passive RMT app, the Misurio and Altoida on their phone. Passive RMT just collect data passively. Misurio, it's an active app. It gives bi-weekly cognitive tasks that are specifically designed to analyze how well your cognitive functions are. And it will provide a score to tell how good you did. The Altoida is also similar. It checks the spatial, navigation, and motor functions of a particular participant. So these 2 are kind of more aimed at Alzheimer's patients. So this would be the first tier, and there will be some participant who would opt in to go through the second tier and third tier. The second tier would be that they would be, we will install some sensors in the car so we can understand how well their driving performance is, and also measure sleep patterns using the Dream device I showed earlier. And then the third stage is that some cases, the participants are also monitored in a smart home that is specially built for this project. So there are some smart homes with some sensors which detect movements, and how you can open the doors if you forget things or not like that. So for these separate tiers, they also get different level of consent to participate in the study. So as you can see, of course, it's a lot of devices. So we also had to integrate with a lot of different devices to support the Reda AD study, and these data ingestions are also done differently. For example, the Misurio and banking app, they send data directly to Kafka using REST API. The Altoida first sends its data to their cloud, and then their cloud would directly push their data into the platform instead of us pulling from their cloud. And some devices like GitHub and Activity, we just get the data from these devices, and the researchers or the study coordinator would get the data from the participant and upload it to the system. Here are some early results from the study. So this is basically just looking into user experience and compliance of the study. And you can see the inclusion criteria. I won't go too detailed into the numbers, but they include all participants from all level, healthy control to preclinical and prenormal to mild to moderate. So mild to moderate AD patients, they do have, they may have troubles actually working with such technologies. But overall speaking, there were different questionnaires per device, or the data source that they were using. But overall speaking, they were quite welcoming of the technology, or they didn't have a lot of troubles using a particular data source or a device. The main preliminary outcomes are that the AD patients are also willing to and able to work with such technology. And it is noticed that there's a slight lower compliance in mild to moderate AD patients, but the compliance rates are not significant. So they do think that the compliance rates are kind of independent from which particular disease stage you are in. And it was also noticed that the user experience is reasonably high. So there's participants didn't experience a lot of problems in using such technologies during the study. So just to conclude, it's a platform that started as part of the project, but now it has been used in a lot of studies. It's open source, and it's used in different disease areas, different applications. I think that's it for today. I don't know. I think close to an hour. But I'm happy to take any questions if you have.
Thank you, Ms. Nivethika Mahasivam. We are grateful for the knowledge you shared with us and the effort you took to share your thoughts and experiences with us today. So let's move on to the Q&A session to resolve any questions regarding today's seminar. Our speaker is now ready to answer questions from the audience. You may leave a message on the Zoom chat or unmute your mic and speak.
Hi, Nivethika. Thank you for that very interesting talk. And in fact, over the talk, you answered most of the questions I was building up. For example, you mentioned what sort of diseases that you are looking into, and also what sort of things you are especially looking into, things like how you are trying to handle the privacy concerns that can arise, especially in these kind of applications and when you are trying to merge in multiple devices. Therefore, I would like maybe to bring up, you said that this is built up as an open source project. So maybe can you discuss a little bit about the opportunities that are available, maybe if someone want to contribute?
Sure. Actually, that's one thing that I didn't add to the platform. So yes, it's true. It's open source. It's actively maintained. The Hyve and King's College London are the main two entities who created and still maintain the platform. If you're interested, I think we do also sometimes we do some intern projects, research projects where people can join in. Same goes to King's College London as well. And since last year, we also run Google Summer of Code program, so which will where students, or I think right now anybody in the early career can participate in Google Summer of Code programs. And other ways of contributing can be, now we are also putting more and more effort into sharing some part of the data analytics pipeline. What I have been talking now, the core of the database is really about data capture and management. And that part of the pipeline is open source. But obviously the data algorithms, how you analyze the data, is done by the data scientists, and there's more concerns, IP, etc., etc. So it was not open source. Now we are putting more and more effort into also kind of streamlining that part of the platform. And I think one way you could contribute is to also engage, if that part is more interesting to you, doing the data analytics, you can also look into the scripts and figure out if you would be, willing to work on that area. Another idea could be is that, which I hear from some of the professors that I work with, is that they also like to have an instance of database in their university and run some studies with students, or this platform is used really in really different domains, to study stress in students, stress in employees, etc. So you can also try to set it up in your local environment, try to figure out how the data flow works, and if you would like to kind of improve what's already out there, that could also be an opportunity. Does that answer your question?
Yes. Thank you.
Okay. So if anybody is interested, I think by the end of next week, we will know if we are selected for this year's GSOC. So if any of you are interested, then feel free to check out the website and the GitHub repository of database, or you can write me a message. I'll be happy to answer.
Okay,
anything else?
Yeah, we have another question from the audience.
Sure.
Madam, can you share your experience about the research internship at Synthet? Like, how did you get into it and your key learnings?
Okay. So how did I get into Synthet is, I was a bit ambitious about what I wanted to do for my master thesis, and different students in my master program, we have to find our own research supervisor and find a topic. And I had someone who did the same program. He also did the internship at Synthet. So from him, I got the contact, and I reached out to them and expressed my interest in joining their research as an intern, and they accepted me as one of their interns. That's how I landed there, and the topic was also interesting to me, and my skills were interesting for them. My key learnings, there are, so the topic that I worked in is to build a scalable data preparation system for open data. By open data, they mean that you also put some metadata to the data that's collected. So the data that you have is eventually converted into RDF. And another challenge that most of the data scientists face is the initial stage, the data preparation and the data transformation. And this takes a lot of time. So the goal of the project is to have a system that you can use with the UI. So with the UI, you will be like dragging and drop. You will have like a drag and drop function, which will add a particular processing to the data transformation pipeline. So this data transformation is made simpler. And then the second part of the challenge is to, obviously, we are dealing with big data, so this has to be scalable. So I looked into that and found the suitable technology that you can use and explored how you can build it. So during the process, I actually had to learn Scala and Clojure. Like Clojure is completely different from Java, and you have to use functional programming to work on that. So one of my key learning is that you should be able to, depends on where you are, but in this particular setting, you have to do a lot by yourself. You have to should be able to go into kind of a deep learning curves to get and come to a stage where you can actually start coming up with data or statistics that can give you the answers to the actual research questions or the actual challenge that you're trying to address. Other than that, yeah, I'm thinking, what are the other key learnings? I think, yes, just the ability to like design something on your own together with other researchers and learning new technologies and identifying. Sometimes it's also possible that at the end of the research, you find out this is not the best thing to do. That's also one of the key learning. Any other questions?
Yes, madam, we have another question. Madam, since you have the experience in Sri Lankan software industry and at the same time more exposure to the tech in healthcare, can you give us some insights on the global challenges in healthcare industry, those the Sri Lankan talent pool and startups can contribute to?
So generally speaking, the health tech is really a niche now, and one of the topics that is highly desired is this digital health, building digital health technologies. But also, if you're a tech person, just skills in data science and knowledge in big data technologies and etc., those help. And in terms of like, so generally speaking, there is a lot of need for people with technical background and experience and ideas. So I wouldn't particularly say how it would match to the Sri Lankan talent pool. I think it's applicable to everywhere. And it is possible that sometimes it can be hard to get into a particular sector if you don't have prior experience, because you're working with health data. And in certain conditions, settings, like for example, if you want to get into pharma, then they may prefer if someone has more bioinformatics and pharmacological experience, or if you have worked with other health tech or life science domain, then it's more trustable and appealing for them. Does that answer? Is that helpful?
Yes. So, madam, if there's any video demo that there's a link in your slide, you can you just show us?
I can share this slide. I do have to admit the demo is quite slightly outdated. It does give you some idea about the platform, but there are some modules that are old. But you can have the slides, and you will have the links of what I have been discussing as well. Anything else?
So it seems to be that there are no more questions. Thank you everyone for your questions. And also, in order to improve the effectiveness of our future seminars, we would like to have your feedback. So please spend some time filling out the feedback form by using the link we are now providing in the Zoom chat. Once again, Ms. Nivethika, thank you for spending your valuable time educating us on today's topic. So
Sure.
that brings us.
Thanks, my pleasure.
So
and good luck, everybody. And I don't know, maybe sometime see you all in person.
Thank you, madam. That brings us to the end of today's seminar, and thank you all for being here with us today. Until next time, I wish you all a pleasant night. Thank you.